Hi, we are Velovations with the advisor Steve Lehman. We have 3 sub-projects. We are the dropper post team, and the teams to follow are the electric shifter team and the steel frame team. So Velovations is a biking design enterprise, so we focus in on solving and designing biking-related problems and products. Primarily, we've been working on local projects. There's 14 members. We're working on 3 projects currently, which are the simple dropper post, the next bike, and the electric shifter. So for the simple dropper project, in the center you can see a visual of our current design. Our team members are Summer, Matt, myself, and Ian, and we currently are working with Michigan Scientific.
So a mountain bike dropper post is used to actuate the rider's seat up and down while they're riding. And the up position is used for going on flat ground and climbing hills so you can get a full pedal stroke. And the lowered position is used for going downhill and across rough terrain so you can maintain your center of gravity on the bike. Issues with dropper posts currently are their low reliability. The low cost ones are they don't work very well and they break a lot. The more expensive ones have difficult installation. You have to route cables, maintain cable tension, and they're kind of a hassle. And then the expensive ones get really expensive. You can easily spend $300 on a dropper post, which is not very friendly for people just getting into mountain biking. So our project's set to bridge this gap between cost and reliability. So our main design criteria were making our post that's reliable for the consumer, making it low cost so anybody can use it, and then making it easy to use and easy to install for beginning mountain bikers.
So we began our project work in the spring of 2019 and beginning out with online research, moving on to product testing, and then taking these products and reverse engineering them. And with all this information we gathered, we went into brainstorming to create our own initial design. Moving on to the fall of 2019, we came back and we simplified our initial design with a big focus on reducing part count to increase our simplicity and reliability. So we created a rough proof of concept model, and with all these concepts verified, we then moved on to create a second prototype with better tolerances, a slot to prevent rotation, and bushings for smooth actuation.
In the spring of 2020, we went back to the computers and completed our CAD to correspond with the precision prototype that we've been creating. Here's an exploded view of all the parts included in that document. The mechanism of the post is extremely simple, and that's corresponding with our design criteria of reliability and simplicity. There's just 2 moving parts, a push mechanism, and a locking pin to keep the post in place when the rider is using it. We also received a Michigan Scientific sponsorship this semester, which we have used for bouncing ideas of our design back and forth. And due to the unfortunate situation of COVID-19, we were unable to finish our working prototype, and we were not able to start our fatigue testing for the simple dropper post. Moving on to the future plans, in the fall of 2020, we plan to complete our functional prototype and begin testing on it to make sure it corresponds with the ISO standards for mountain bike seat posts. We would like to perform a price analysis as well and create a user manual and installation manual for the post. Thank you.
We're the electronic shifting team for the Velovations Enterprise, and our team members are myself, Jared Russell, Jacob Bilkey, Joey Eckhart, Nilan Holly, and George Povich.
So the electronic shifters that are on the market today, the electronic actuation is located inside the derailleurs themselves, and the derailleurs that you buy off the market might require cable routing up to the handlebars. Our shifting mechanism sits on the bottom of the rear triangle, and the only connection is the shifting cable routed to the box, which is only about 6 inches long. So the pros of electronic shifting: it allows a faster shift under load, it allows consistent shifting, it reduces chain rubbing, it has multiple shifter locations, and it doesn't require cable stretch, and it has a potential for automatic shifting in the future.
So although there's a lot of benefits that come with electronic shifting, there's definitely some issues with it too. One of them being the large expense that comes with it. you can easily expect to spend $300 or more on a quality wireless or electronic derailleur. And that's not including the rest of the upgrades that you're going to need, like cassette, chain, shifter, that kind of thing. Our system was estimated to be roughly 1/7 of the price of a traditional electronic shifting mechanism. So that's one definite big positive. The other detriment to some electronic shifting devices on the market is you might require a new bike. If your bike's older than about 2005, it's not going to be compatible with the 11 and 12 speed drivetrains that are pretty standard for these high-end electronic shifting mechanisms.
With these issues in mind, we set out some project goals. We wanted to make a wireless electronic shifting mechanism for all. We wanted to make this version adaptable for older bicycles so people wouldn't have to upgrade. We wanted to make this model cheaper than the professional models that were extremely expensive. So we made some design criteria, and we want it to be easy to install, easy to use, and low cost.
Our first initial design was to create a brushless DC motor attached to a gearbox that would pull on the shifting cable to move your derailleur up and down the gears. This proved to be an inefficient system, and we had trouble with the motor, so we switched to a servo. The servo then is a more direct shifting route, and it is mounted to a case that holds the servo, the battery, and a solenoid brake if we decide that it's needed. So this is a all compact unit to be sold on the market.
So as we continue into future semesters, we are going to be building up our prototype and testing it. So we're going to test the strength of the solenoids and the servo to see if they can handle the load. We're going to be testing the battery life, and we're going to identify if a solenoid brake is even needed to lengthen our battery life. We are also going to be performing a final price analysis, as well as creating an installation and user's manual along with an app, so that way anyone can install this on their bike with ease and be able to change it to whatever setup they have.
This is Velovations' next bike project, sponsored by AK-Tube. Team members include Kurt Eaglehoff, Tristan Hunt, Forrest Collins, and Jacob Ashleman. The objective is to create a lightweight, low-cost bike frame that competes with the current bike frame materials out there. To do this, we are using X-Tube 1200 NT30 tubing. This tubing was designed by AK-Tube and is 40% less expensive and stronger than steel. Currently, there are three main bike frame materials: carbon fiber, steel, and aluminum. X-Tube is attempting to outperform steel and aluminum. The project plan is to do research on the plausibility of this, to design the bike frame, then do analysis on the design to confirm its strengths, then have the frame built and do further fatigue testing until it succeeds, then to build the frame up and do field testing. The design will be based off of a typical hardtail mountain bike. With the help of Moonlight Cycles, we were able to drop a design. As seen in the image, there will be three main tubes that will be X-Tube steel, while the rest are standard 4130 steel tubing. During the process, finite element analysis was performed to provide predicted stresses that the frame could experience during the life of the frame. Modal analysis was also performed to compare the riding characteristics of the frame to another aluminum frame of a similar design. After designing the frame, we sent the tubes and other associated components to Detroit Bikes to have the frame welded up. With weld recommendations from AK-Tube, the frame was then built. Once built, we began fatigue testing the frame. The test would load the frame 1200 newtons out and 600 newtons in. We began to run the test only for the frame to begin cracking shortly thereafter. Upon further analysis, we realized that the load characteristics within the FEA were opposite of what they should have been, which gave us faulty data. After realizing this, we fixed the FEA. We found that the new refined FEA correlated with our fatigue test, and we found that the frame fatigued because the frame experiences stresses higher than the limits of the material. The solution was to add strengthening members to the frame, which is something that many manufacturers do. This is an easy modification that increases the strength of a high-stress area of the frame. The strengthening members include designs similar to those in the images below. With these modifications, the FEA should perform a successful run, and then we can get another frame built. Currently, Detroit Bikes have been asked to build up another bike with the desired strengthening modifications. Due to workplace restrictions, our team will be outsourcing the frame fatigue testing based on Detroit Bikes' recommendations. If all goes well, we will have a successful frame that has passed testing. The next step will be to build the frame up and field test it. Once complete, the bike will be sent to AK-Tube, and there it will be displayed at their headquarters. Thank you.